Hi, good morning. Today we are going to explore the bus system used in software-defined vehicle. In previous sessions, we have discussed software-defined vehicle in detail to a certain level. Right now we are going to explore a bus system used in software-defined vehicle. What is that? It is automotive Ethernet. This bus system or link communication network link is used in between zonal controller and high performance computer that we have in the middle of the car. Right. For a high speed data exchange, they go for this automotive Ethernet. We are going to explore that bus system in detail in this session. Right. How the evolution of IEEE 802.3 standard has been started right now. Let us discuss that. Actually, it was started as an experimental project in before 1980 by a corporation called Xerox PARC. They developed an experimental network bus system to exchange packet in between two nodes, right, with the speed of 2.94 Mbps per second, which is a very low speed, right? But still it can exchange the information between two network nodes. That is how it was started, right? And then they did stop their research there. They improved the standard by connecting with other industries, those are working in that same field, called a Digital Engineering Corporation and Intel. These were the organizations. So those are working in the semiconductor field, the semiconductor and network field. Right now, with the help of them, they have come up with a new standard which can exchange the information at the speed of 10 megabits per second. So they have increased the speed of the system in 1980, right? And it becomes a joint project between these three organizations: Digital Engineering Corporation, Intel Corporation, and then Xerox, right? So in 1983, right, they have named it as a local area network standard for communication right now. So in that, they have started using something called carrier sense multiple access bar CD. So the CSMA is there in CAN bus system as well. In that we have a detailed course module in our channel. You can refer it. I think most of them were free. You can go and refer in that. I think mastering CAN bus system is the topic playlist. So you can search in our in channel and can find that detail about the CAN bus system. In that we have discussed CSMA elaborately. In a elaborative manner, we have given more detail about CSMA. The same CSMA is used here as well, and it is an off duplex communication right now. So because the carrier, that is network medium, is shared between different nodes, and they use an off duplex communication. This is what the initially they have come up. They started standardizing it with the name like standard for local area network, like that it has been they have developed it. Then it went for IEEE approval, so and it is approved, right? In 1983 this was done. In 1985 they published the first standard document, IEEE standard 802.3, 1985. This is a baseline document for whatever the development that happened in automotive Ethernet, in Ethernet in general, right? It is also used in automotive as well right now. So this is a baseline document. It has been published in the year of 1985, right? So then in 1997 they started implementing something called a full duplex communication. So which is like connecting two peer-to-peer nodes, right? Using some new technology right now, using switches and other things, bridges and other things. They started implementing a full duplex communication. Because of this full duplex communication. Simultaneously, each node can transmit and receive using an independent link right now. So because of that, the network contentions is reduced, and we have a high speed connectivity without any problem. That is what the improvement that happened in 1997. In 2012, they renamed the standard. Initially, it is a standard for local area network, and then they changed the standard name with the standard for Ethernet. So that is what the new name that is given to this standard, right? From 1985 onwards till today, there were a lot of developments happen in this standard. Those were aligned by adding a suffix to the existing standard 802.3 suffix xy. So this xy can be an AB like that. They can have a different suffix, right? Each suffix will have their own implementation, a new addition to an existing standard, right? That's how it has started and evolved. Next, we have to know how this CSMA or CD of Ethernet bus system works. We know how the CSMA or CD of CAN works right now. There, every node will listens to the bus. If their bus is free, they will start try to transmit. If more than one node try to transmit at the same time, they have something called as an arbitration to pick the winner right now, who can engage with the bus to decide that they have such thing. But what we have here, so here in CSMA or CD of 802.3, what has been implemented in this? Here also the node sends the carriers. Right now they look for bus free. Maybe they may maintain some voltage. Whether that the voltage is reaching in that point, they will monitor that in the physical link. Right. Once they come to know that bus is free, right? The each node who want to transmit something will try to access the bus and will start transmitting it. So here there is no arbitration, the concept of arbitration. When the multiple node try to transmit at the same time, there will be a collision. If there is a collision, they allow it to happen for some time to propagate the jamming or collision to the every node. Once they confirm that there is a collision, then they do a random backoff. Each node which is engaged in the transmission at the same time will go for a random backoff time. That means they will take a random time. They will wait for a random time and will retry the bus. When they are trying it again, if the bus is free, they can successfully transmit their packet and can complete the transmission. This is how the half duplex communication of automotive Ethernet or Ethernet in general works. From the day of release, that means from 1985, there were a lot of improvements happened in this bus system. Those were aligned under different amendments. These are some of those amendments. There we have a standard called 802.3U, meaning suffix U, which is a fast internet, which has a capability of transmitting 100 Mbps per second and was released in 1995. Then we have 802.3Z, which is called as gigabit internet, right? Has a capability of doing exchange in the order of 1 GB per second and was released in 1998. Then we have 802.3 AB, which is also a gigabit internet, but here the gigabit per second, 1 gigabit per second transmission happens in a copper wire. They have achieved that in a copper wire and was released in 1999. Then we have 802.3 AE, which is called as 10 gigabit Ethernet. right? The capable of exchanging information in the order of 10 gigabit per second and was released in 2002. Then we have 802.3BA, right, which is a 40 gigabit Ethernet, has a capability of exchanging information at the rate of 40 gigabits per second and was released in 2010. Right. Then we have 802.3BJ, right, and 802.3BM. These are called as 100 gigabit Ethernet, has a capability to exchange 100 gigabit per second and was released in 2014. Finally, we have a very high speed 400 gigabits Ethernet, which is aligned under 802.3BS, right, has a capability of exchanging information at 40 gigabit per second and was released in 2017. These are few examples, examples of amendments. There are many, right? So we cannot bring all of them here. We will study and explore what is needed for automotive right now. So here we have a clear explanation about this half duplex communication, how it works, right? We have a DTE, data terminal equipment. They are listening to the bus, right? The moment they come to know there is a, even the bus is free, they try to transmit. When they try to transmit, if there is a collision, there will be a back off, random back off time, and then they will try it again. So here they have listed them as point. The stations share a common medium. Each station listens before sending. If collision occurs, it is detected, station back off and retries. This is how the off duplex communication of Ethernet bus system works. So here we have a detailed diagrams, right? Carriers and station A want to transmit. It listen to the medium, right? The medium is idle, meaning how they will judge the medium is idle based on the voltage level, right? If they reach certain voltage level, they will assume that the bus is free, then they will try to transmit. While they are transmitting, this data terminal equipment will do that in serial form, as we do a serial transmission in CAN. They also do the same here, like they are transmitting the bits in bit serial form, right? A is transmitting, B detects the activity and differs. Right. Then the collision detect. When both of them are trying to transmit the same time, there will be a collision. If there is a collision, they allow it to happen. That is called as jamming or ensure collision propagation. Right. Both stations continue transmitting for a predefined jam period. Jam signal ensure the collision is seen by all stations on the line. All stations on the line. Then back off. Both stations stop transmitting and remain silent for a random back off time. So that is called as back off. Then attempt again, right? After back off, the station whose back off time expires first, retries transmission. Like that only this half duplex communication works. In full duplex mode, we don't need any CSMA or CD. Let's see how it works. Dedicated link between two stations, simultaneous transmit and receive, no collision. CSMA or CD algorithm is not required in this case, right? Those were the difference. Right. So here we have a detailed diagram. Simultaneous transmit and receive, no contention for the medium, no need to differ, monitor, reacts to the activity. CSMA or CD algorithm is not used. Right. When we go for what is the right time to choose the full duplex mode, or when to choose the full duplex mode? So in order to perform a full duplex communication, your physical medium should support the simultaneous transmission and reception without any interference. So the first criteria is your physical medium should support it. There are exactly two stations connected with full duplex point-to-point link. So by facilitating a bridge which establishes the connection between two nodes, there should be two nodes which is linked in a peer-to-peer manner in order to perform a full duplex. For that, they can use the switches and bridges and other stuff. Both stations are capable of and have been configured to use full duplex operations. Both of them should be configured to full duplex communication. If, for example, if one is configured for off duplex and another one is full duplex, again we face the same issue. Right? The most common configuration for full duplex is we have a full duplex supported nodes. Those were connected via a switch or bridge. So the switch connect them in a peer-to-peer manner so that they can do a full duplex exchange between them. Okay, team, that's all for today. We have a short introduction about automotive Ethernet. We'll explore it further in upcoming session. Thank you. Thank you for watching.